Hello learners. So in this video, we are going to demonstrate one live project of machine learning where we are going to build, let's say, a churn prediction model using custom loss function. Okay. So what's a loss function? That is something we ourselves will define the loss and then we'll train the model based on the custom loss, and then we'll validate our results whatever we find with the custom loss compared to the normal loss function. Okay, and let's see if there is any difference or not. And in that way, if let's say your business goal or your business data is deviating from whatever blueprint we have in the basic frameworks like TensorFlow or PyTorch, so we can build our own neural network loss functions as well as metrics or targets, right? Based on whatever data we have. Okay, so before jump into the project, let's just see or visualize how to build custom loss functions. So for that, if you see here, we are importing TensorFlow and we are importing Keras, right? So let's say we are just, these are dummy thing, right? So we are creating two numpy arrays. So these are our feature inputs and these are our target labels. Okay, a simple regression problem. And in model we are building one unit neural network. Okay, so we are defining only one unit and this is our output layer. Okay, and we are passing one scalar, okay, this x, and we are expecting this output. So it's probably some combination of y equals to mx plus c, right? And let's just fit the model. Okay, so in this case what we are using optimizer of SGD and a loss of mean squared error. Okay, so this mean squared error is already predefined. Either you can use this one or you can use the loss functions that TensorFlow provides, right? So if you, as we have imported, right? So here dot errors, right? Dot, if you see all the options, right? So I guess in losses, right? Yeah, from losses you can import this mean square error, right? Mean square error. So all type of errors are available, right? If I have to import the mean square error, how can I do that? I can use this one, right? This MC method. Okay. Right. So yeah, this is how you can import. So what is the benefit of importing this object compared to this string? Here you can find all the hyperparameter tuning options for losses as well, right? So here if there is any default values it is setting in this method, right? So you can see and you can definitely update according to your need, right? So let's just quickly run this model, right? So I'm not going to run all of these models, right? So it is you can download this notebook and you can run it for yourself. So yeah, once this is done, you can print the output. You can see the output will be for 10 and the output will be around 19. Okay, so mostly the formula here what we are following, right, in this input is 2x minus 1. Okay, so if you see for 4 you will have 2 times of 4, 8 minus 1, 7, right? So that means your model is doing good, right? Now how to change this loss, right? So currently my loss is mean square error, right? So let's say I'm going to define Hubble loss. So what's the Hubble loss? If you go and see, okay, so the Hubble loss function, it gives a penalty included. So it is normally used in regression problem where the regression can be prone to outliers. So this is how the loss function of Hubble loss looks like. Okay, so for let's say any delta or a threshold, basically, if my loss or error term, A is the error term, is less than or equals to this delta value. So what is your delta? Again, you can find everything from this uh, notebook or this wiki page, right? So yeah, then your loss function will be defined as a square, that means error square divided by 2. Otherwise it's simply multiplication with the delta terms, and then absolute of your error, then half of the delta. So this is your total Google loss. That means it's a custom function, okay, nothing else. So how you can define this in code, that we will see now. Okay, so yeah, for building this kind of loss function in Python with Python custom functions is pretty much easy, right? So what you will require for loss function, you require a true value and the prediction value, right? And let's say the threshold for doing this Hoover loss, for building this Hoover loss, right? That means this one, this delta term is, let's say, 1 in our custom project. Okay, let's just copy this. Let's just paste here, okay, so that we will have understanding. Okay, so this is our whole code, right, that we have to code for our loss function. So this delta is nothing but this threshold here, which we are validating, or which we are providing as hard coded as 1. Then this a is nothing but the error term, that means your y true minus y predicted, this y minus fx. So that's our error term, a is y true minus y predicted. Then first we have to define this condition, we have to validate this condition, right? So if, for validation of this condition, as we have mentioned, right, a is less than equals to delta. So how you can define a is nothing but your error, this variable you call here, and we have seen that a is here as the absolute form, right? So tf.abs will give you the absolute value of the error in TensorFlow. So this value has to be less than equals to threshold. This is the condition, okay? So and we are storing this condition of Boolean operation in a small error, okay? Now we have two errors, right, defined. So for the first case, the error will be your error square divided by 2, right? So how we report, it's nothing but tf dot square will give you the square divided by 2, right? And in this case, it's a threshold multiplied by absolute value of the error minus half of the threshold. So until now it's pretty clear and damn easy, right? So finally we are normally how we are going to return tf dot where for our clause will pass the condition. If it falls in the first, we'll return the first error. If it falls in the second, we'll return the second error. So this is how you will define a loss function. So now let's say this loss function, if we run, it will be loaded in our workspace, right? So once it is loaded in our workspace, same we are defining another sequential model with same thing. The only change here will made that now we'll call this loss function instead of, let's say, in mean square error or this mean square error TensorFlow object, right? So what will it will do, it will also compile and it will run, and it will now compile on this loss function, and it will give you the output. Okay, now next is let's say I'm doing one wrapper. Okay, so why we need one wrapper function? We need one wrapper function because currently this loss function, right, this threshold, what we are passing is in hard coded, right? So what we'll do, we'll just create another function that will accept this threshold, right, whatever based on the actual runtime value, and then it will compute the same Hoover loss and it will return the output, right? So how we are going to code that? Similar to same thing, right? Whatever the previous code, we'll just copy paste as it is. Just we'll create another function, and in that we are going to pass the threshold as parameter, and then we are just returning the output of this function, right? And your threshold value it will take from this parameter, right? So it's called a wrapper function that we are wrapping in top of this Hoover loss function, right? And then again, if we define the sequential model with same thing, nothing changed, and then we can find, I mean, we can share we can pass this custom threshold values, right? So this is the benefit of your custom loss functions, right? So you can now implement different parameters, right? And based on this, it will predict you the output, right, of our same array. Now, what we'll do, there is two things, right? So these two things are pretty good, but in normally, generally, what we'll do, we'll create a class. We'll create the class for this custom loss, and then we'll call this method from the directory. Okay. So how to create a class function? How to create a class basically in Python with the class definition, right? So in this class definition, let's call it my Google loss, and let's call the loss module. Basically, let's call this loss class that's actually situated in our TensorFlow directory, right, or TensorFlow module. So what will be the benefit that, or whatever methods, right, are there, or what are the whatever properties are there in this loss class, we can utilize the similar methods here, right? We can use the similar methods and we can redefine. So it's called inheritance property, right, for Python. So here you can see we are just defining the constructor here, right, with the init, and in init we are just passing that, okay, my loss can accept one threshold attribute, right, and the default value is 1. So once that is done, we are just calling this super. Okay, this super will give us the benefit to call any method that's already available in loss, right, and we can modify according to this. Once calling this, we just initialize this threshold value. Okay, so set this threshold of that the user will pass, or whatever default value has as this threshold, and then in the call function already available in this loss class, right, we will define the same my Google loss function. Okay, so instead of my Google loss, now we are defining the same thing in this call function. So same, first error calculation, then condition checking, then the first condition value, then the second condition, and then returning the same thing. Okay, so once this is initiated, then you can see we can directly call this loss function, okay, from the class, and just by passing the parameter that it accepts. Okay, and that's it. That's it for your basic custom loss modeling, right, based on Google loss. So next thing will be the obvious project that we are going to do is a telco customer churn prediction with custom loss initiation, right? So this is the overall definition of the project data set. You can go and download. So you can see there is multiple, I think 1600 codes are already. Okay, so a little bit about the data set. So you have 21 columns, right? So if you elaborate here, you can see all the columns mostly are object columns, and there are some numerical columns. So understanding this thing is not our priority here, right? We'll see how in a actual data set we'll implement this custom loss and how to compare the results based on that, right? So it will be a very fun project to work with. So let's just import the data set first, right? So once you will import the data set, you can visualize the first 6 as a header. So you can see we have customer IDs, then we have the gender of that customer, then whether they are senior citizen or not, whether they are partner or not, whether they have dependents or not, their tenure with telco, then their phone services, okay, either they're opting for phone services, okay, whether they have multiple lines, okay, whether they have internet services, so which type of internet services they are using, is there any online security, blah blah, then the device protection, tech support, streaming TV, all these features are there, right? The monthly charges, total charges, and whether they are staying with us and not staying with us. Now this kind of problem, right, let's say churn prediction, its churn prediction is basically a binary classification problem, right? But what problem you will see with this binary classification problem is that you most of the customer will not churn, right? So let's say I'm opting for a data service of let's say Airtel, right? So the probability of me shifting from Airtel to Geo is very less, right, on a day-to-day basis, because no one does that, right? So that's the business operation. But let's say very few amount of people, right, for different reason, right, whether network is not available or they're not satisfied with the service, they churn from the in the company, right? So this data, okay, so prediction of that is very crucial in this case, right? In this kind of a problem, right? Why? Because if the company will understand what are my prior reason or what are the features that influence a churn, right? Then they can work on it. They can identify the potential churn customers, and they can convert them as non-churn, right? So in this case, accuracy of the model will not be as important as prediction of the positive class of churn, right? So in that case, your normal binary cross entropy, whatever we normally use, right, as a loss function for binary classification, will not make much sense, right? In this case, we have to give much more weight towards the positive cases compared to the negative cases, right? Because it is an unbalanced data set, as well as the positive classification is much more important than the normal negative classification, right? So we'll see how we can implement the same using custom loss function. So before that, this is the target distribution of churn. So you can see most of the accounts are non-churn, and some of them are churn, right? So this is a highly imbalanced data set. As you can see, more than 5,000 clients, they are non-churn, and around 2,000 clients within this 7,000 is churn. So 2 by 7, if I do, around 30% data we have. So it's not a 50-50 distribution, right? So this is the first thing that you have understood, that the target variable, from the target variable, that my data is very unbalanced. Now next is just doing one correlation map to figuring out the high correlated properties, right? So here it will not make much sense, because most of these things are basically objects, right? So we'll just ignore this one for now, and we'll see the later correlation maps. Okay, so our main focus in this project will not be on EDAs, right? Will be our model accuracy will be on how custom loss we can use, and what is the benefit of using custom loss in this kind of problems, right? So data science is not always about following same path again and again. And if you are just following if you are still with me till now, right, I will suggest you to be patient. It will take time, but if you go through, like, let's say 20 or 30 or 40 use cases, right, then you will become a very good data scientist, and you will have a very good understanding, and you can give correct solution to your clients, basically, right? That will in turn increase your value in the market. Okay, now again, there is, I think, only two numerical features, tenure and monthly charges. So we are just doing one distribution plot to see, okay, what's my tenure looks like. So you see there's a bimodal histogram we can see with a mode value. I think here, I think, range from 5, I guess this is for tenure, 5 months, and here again in 70 months, okay, around 70. And then again, monthly the charges, monthly charges. So it is kind of tilted towards this left, so negative skewed or left skewed, you can say. Okay, so where your charges are normally higher, and there are some accounts there that has low charges, or very few accounts, and there are some accounts, okay, that has the highest peak or mode, that is very less what charges that they used to pay, right, the monthly charges. So this is normally what it looks like in case of any business, right? So there will be some good customers that finds the service very trustworthy. There would be some inactive users. There would be some users that use this service as secondary, right? In case of a telecom domain. So yeah. Now next, doing some box plot with numerical features. So here you can see the median of normal median for tenure for non-churn people ranges from 40 months, but those who are doing a churn, it's normally 10 months, right, is the median. And interestingly, there are some outliers identified by this box plot that falls outside of the range of your IQR. Okay, so that has a tenure of more than 70 months. Okay, that means these points are really disturbed points, right? So those customers are really pissed off that after using 70 months of continuously for the 17 months continuously with one service, they has to switch or they has to churn, right? So this thing company needs to give more importance. Okay, and yeah, again the box plot for monthly charges. So you see now the monthly charges surprising, right? For churning customer who churns more has a higher median than who does not churn, and it is pretty much obvious, right? Because in your non-churn customer you have a very high amount of data where most of the customers might be inactive, right? So yeah, I'm not going to much more details, but yeah, understanding the problem functionally will give you a clear advantage and edge while solving a data science problem, right? Now, if you plot the categorical distribution, I'm just only plotting the partner or and gender. So you can see, okay, there is nothing like to identify from this, right? From male or female, you can see even whether it's male or female, the churning condition is the distribution of churn are more or less similar, right? And if you see the count of partner by churn, so if you see if you are a partner, then the number of it will all make much more sense if you do a percentage calculation, but still you can say, okay, and if you are a partner, then the chances that you are going to churn is very less. Okay, yeah. Now, if you do a pair plot between the numerical features, you can see the distributions of those who churn and those who does not churn, right? Same thing that you have seen in the histogram, and we can identify the peaks, okay, here and here as well. So this tenure may the peak of tenure and the peak of monthly charges, right? So it's a clear indication, right? The monthly charges for non-churning or regular customer is much more higher. Okay, now next, this is a missing values heat map, which is empty box, completely indicates that there is no missing value in this data, right? So now what we are going to do, we are going to drop the relevant rows, that means our customer ID. Then we'll encode all the categorical variables with level encoder. Okay, so if you don't know what's a level encoder is, I'll highly suggest you to search on internet for your scikit-learn. Okay, and then we are just storing all the features that X and all the target as Y, which is nothing but the churn value, right? Then we are using train test split of scikit-learn, and then we're just splitting the data based on 80-20 split. Okay, and once that is done, we are initializing standard scaler for scaling the data, and then we are just training we are just scaling the train as well as test data. Okay, so this fit transform is for training and transform is for testing. Once that is done, we are importing a TensorFlow model, and we are just defining one sequential model with the very basic two-layer architecture, with the first layer having 64 hidden units with railway activation, and we are passing the input shape will be from our all the columns dimension, right? So xtrain dot shape 1, the first column shape, so that will be our input data. Then in the next layer we are just having 32 hidden units and activation as ReLU. And in final layer, we are calling sigmoid, and it's a normal classification problem, right? And that's it. That's how we are building the model. Now, next thing for model is again, right, your model compilation, where you will be requiring this optimizer as well as your loss function. And here we are not going to use the standard binary cross entropy, right? We are going to use a special weighted binary cross entropy. So for that, we are importing TensorFlow backend. Okay, and once it is imported, we are just calculating the binary cross entropy, which is nothing but calling the binary cross entropy function upon y true and y prediction. So once it is calculated, what we are going to see, we are going to apply weights. Okay, so we assume, let's say for non-churn, right, the weights will be weight 0, and for churning class, that means where we have to give more weights, right, it's a weight 1, right? So by assuming this, our weight vector will be your true value. Okay, when we have y true times weights 1 plus 1 minus y true times weight 0. So how we have to understand this one? So let's say your class is 0, right? That means your y true will become 0. That means your weight 1 will vanish, right? Then whatever you will have only weight 0, right, in your weight vector. And let's say the opposite case, when you have class 1, then you will have only weight 1, right, in your weight vector. Okay, so then we have to multiply this weight with this binary cross entropy, right? So this is how you will define the weight vector. You have understood, right? This is how you are going to define the weight vector, and this is how you will just multiply it with the binary cross entropy. So it creates another custom loss function, and once that is created, we are just returning the mean value of the loss. Okay, so this is what your whole loss function looks like. Okay, now what you have to compute here, your weight vector, right, which is a variable. Right now it's only variable, right? It does not have any value, right? You have to compute this one. So for computation from scikit-learn utils, we are calling this class weight module basically, and we are importing compute class weight. It will compute the class weight, right? So where we are passing this balanced approach. Okay, so if you see what's this compute class weight, let me just do it. Okay, it estimates, sorry, what is that? Yeah, so if you see, so what it does, it estimates the class weights for unbalanced data set. That's our target, right? So how it does, it gives a full reference and return value and the parameter. I'm not going deep, big details into it, but yeah, this is the method, and we are passing this balanced approach with class value as 0 and 1, and y train as our value of y. So from this we can definitely get the value of weights, right? So class weight 0 will be the weight for non-churn predictions, and class weight 1 will be the prediction for weight values for your churn prediction, right? And finally we are returning the weights. Okay, so once that is done, we are getting the weights, right? Basically we can use this as parameter. This parameter we are going to pass into our loss function. So as you can see right now, we are just wrapping this loss function on top of this loss function. So directly we'll call and we'll pass the parameter loss, right, like the Hoover loss that we have just discussed in the very first of this tutorial, where it is here. You can see this is the wrapper function. So this is how you can utilize, your learning into action when you are building let's say machine learning problems for your client or yourself, basically, if you're doing self-study, right? So we are just in loss, we are not calling binary cross entropy, we are calling our custom function that we have just created, weighted binary cross entropy, and in weights we are passing an array with weight 0 and weight 1, right? And then we are just doing same thing, model.fit, and with this fit we can see we are achieving a accuracy of 80%. on training data and 76% on validation data. Okay, and then if you just print the accuracy of train versus validation and loss function, then you can see for training the loss is decreasing very smoothly, but for validation the loss is increasing, right, after certain epochs. I think after epoch from here, right, it is increasing. So you can see 5 7 7, you can mark it down, right? And here also you can see the accuracy of validation is very fluctuating, right? And it is indicating that's a kind of overfitting kind of a problem where your training accuracy is increasing with every epoch, right? So this indicates a serious problem with the code actually, or the model. So your model, you have to, it indicates that the model is not learning very much efficient or much more things. So what we do, first thing we'll do some feature engineering, right? So what we have done, we have added another column called total charges. Okay, so where we have added then the second one, what we have done, uh, we have divided the total charges by the monthly charges, and we have taken the change ratio from that. Okay, so we have added +1 with it, so that in any case, right, your monthly charges become 0, then you can avoid this zero division error. Then again, we have created the tenures from as you remember, right, our tenure were a numerical feature from 0 to 70 months. So we'll just bucketized it. Okay, by using this pd.cut method, right, it will create the buckets and will label them accordingly. Then encoding, the portion of encoding required to convert this object, basically this object class, to one hot encoded values. So that thing is done, and then we are just dropping all the NA values, right? So this is a simple feature engineering that we have done based on whatever we have seen so far. Now next, what we are going to do, we are just doing plotting one correlation matrix, right? So in correlation matrix, we can see our tenure has a very high correlation with tenure group that we have just created, right? Tenure group and tenure has very high correlation. It should be, right, it's the same data. And also we have very high correlation of tenure with contract. Okay, so this kind of correlation makes sense. Let's say if you are doing with multi collinear, dealing with multi-collinear data, right, where you have, let's say, certain features that are partially dependent on each other, or can have influence of let's say one feature have influence on the other one. So what you can do, you can save your model's training time, right, by just removing one of them, because mostly those features represent similar kind of thing. So here what we are doing based on this value, right, whatever values we can see, we are selecting a threshold of 0.1. Okay, and we are only selecting those features that's having absolute value, okay, with churn, that have a, high correlation with churn, right? So if you see most of these features, right, with, if you consider churn value here, right, so in this case, if you see the churn values were here, right? So if you see churn with gender makes no sense, right? So if you consider this line only, you will find all the dependencies. And what we are doing, if your absolute value is less than 0.1, we are dropping. That means for senior citizen, we are accepting this feature. For partner, we are accepting this feature. So for this multi-line, we are just deleting. For phone service, we are deleting, right? And if you think normally, right, also this kind of feature, this phone service, multiple lines, it makes very less sense. Okay, for some customers probably it will make, but in general, right, whether you have phone services or not with this Airtel or whatever telecom company, right, you are working with, it does not make much sense. Okay, let's say you have a data connection and not phone service, right? So yeah, probably the data is identifying towards that conditions or directions, right? So that's what our initial approach will be. Okay, if I have a correlation value less than 10% or zero point 0.1 basically, so I'm just not going to pick that feature for our model selection. And again, then we are splitting the data, right, based on train, test, and on 80 and 20 basis. And now we have made some serious improvement in our model also, right? Previously, if you see, our model is only 64 neuron and 32 neurons, right? So now we added 128 dense neuron. Then we are doing normalization, batch normalization. Then again, we are using a dropout to avoid overfitting. But because we have seen, right, our initial learning models are showing that we are getting a good amount of overfitting with the model. Then again, 64 units hidden layer, then again a dropout with batch normalization, then again a 32 layers hidden unit, and finally the output layer or sigmoid layer, right? Then again, what we are doing now, we are defining early stopping and model checkpoint callbacks, right? So these are some improvements here we are currently doing to check on the validation loss. Basically, we are early stopping based on the validation loss. Okay, and we are doing the storing the best model basically as best model dot krs as we are using this TensorFlow, right? So dot krs is the saving your storing option for your model restoration. Okay, and on what basis we are judging? We are basically judging on basis of validation loss, right? Then again, we are compiling, let's say this optimizer, we are using Atom here, and loss we are using, this is main, right? In loss we are passing this custom loss that will give more weight towards our churn values, right? And the metrics we are trying to print is accuracy. And then again, we are training the model. And then again, if we plot, now you can see your validation accuracy is higher than your train accuracy, right? Which is also very rare. And also you can see a kind of smooth curve, right? As we are, it's only 20 epochs, right? So you will have this kind of fluctuation, right? With this only 7,000 data points. Okay, but you can see it is a much improved version than whatever whatever graph we have seen in the previous case, right? So again, okay, so this is what your model building. Now next thing, what we are going to identify, okay, let's say I am having this custom loss model, right? What will happen if I don't use this weighted binary cross entropy? Instead of, I'm just going to use this binary cross entropy, is there any changes in feature importance I can see, right? Okay, so again, what we are doing, we are again initializing the normal loss as our binary cross entropy, and we have our custom loss, right? So we are defining our normal loss function here. That means everything, the architecture will remain same. Only in loss function we are changing it to custom loss to normal loss, right? And then we are training this, and then we are printing the F1 score of both the things. So if you see, the custom loss has an F1 score of 64, and the normal loss has an F1 score of 62, indicating that custom loss is doing better, right? If you see the accuracy, the normal loss has much higher accuracy, right? But it is failing on the recall. It is failing on the recall, right? Where we required more, importance, where we need to give more importance, right? So what is happening, your custom loss is failing on precision and overall accuracy, right? Which is not a big deal, because our target in this use case, right, is we have to classify all the churns correctly, most of the churns correctly, right? And that's what this custom loss function is doing, and custom loss model is doing, right? It is identifying most of the churn cases correctly, right? So overall accuracy might not be a big classifier, big deal for our use case, right? In our use case, our focus should be on this recall value, right? So as you can see, by using a custom loss function, you can train your model, and you can achieve what you wanted to achieve from this from the machine learning work, right? You have to understand the nuts and bolts of machine learning very well, right? And then again, a similar model comparison, if you can see, this is the custom loss function. Custom loss accuracy, basically this is the accuracy graph for our custom model. This is the accuracy graph of the validation data set of our custom model, and similar kind of thing. This green one is training accuracy, and this red one is my training validation accuracy on normal loss. So it indicates that my normal model is performing much better compared to my custom value, or my custom model, in terms of accuracy, right? But if you change this to your precision recall value, then you will see a different scenario, and that is what it makes the difference, right? We need the recall value to be corrected or to be maximized, and not the accuracy in our use case, right? And then we're just importing confusion matrix, and we are plotting the matrix to see if in this case, you see, in case of normal losses, it has correctly identified all the churns. Based on all the churns, it has currently identified only 221 cases, right? And it failed to identify 150 cases of churn, right? So it's a big deal in our in case of telco, right? Whatever the client's data you are working with. But in case of this custom weighted loss function, right, or custom weighted loss model, only 50 cases it is failing, and more than 320 cases it is passing, right? So these two values are making the difference. So you have to understand what's your use case is, how to identify your use case in your machine learning problem, right? And then you have to build the model in such a way. Otherwise, simple, just copying and pasting codes from internet and trying different hands will not make much sense to your business client's data. Okay. So once that is done, what we are doing, we are just printing the visual importance of the features of these two different models, just to identify, okay, by changing this loss function, right, is there any feature importance that got shifted, or a significant change in the feature importance. So for that we are using this SHAP. I hope you all are aware with this module, right? It plots the model importance of the features. So I can see that for our custom model, right, this monthly charges and tenure, these two are the highest prioritized features, with monthly charges contributes towards the higher value, higher SHAP value, right? But if I see on the balanced approach or normal binary entropy value, right, I will see tenure gives much more importance in the model prediction compared to monthly charges. And probably that's why if you compare the box plot, right, if you come see the box plot, you will also see your monthly charges for the churn customers, right, here is higher than the monthly charges of your non-churn customers, right? So probably this feature is making much more sense when you are trying to predict a positive class in this churn classification classifier, right? So that's how you have to understand your basic problem, the requirement of the stakeholders, and you have to build, identify and solve problems based on whatever data you have. But you have to use this kind of metrics and this kind of understanding, right? So right now in this project, what we have done, we have learned the use of custom loss function, and we have implemented that into a dummy data set or project data set, right? So yeah, I hope you can take this notebook, and from this notebook you can build something more cool, more fun, and you will understand much more. So if you like this video, please like, share and subscribe this channel. And if you want to learn more about machine learning, data science and artificial intelligence, and if you want to see much more this kind of tutorials, please subscribe to my channel. Thank you.